And this EFGH, this is iterable number 2, right? And zipped string as so I've done list ZSTR. So this print statement will generate this line of code. This zipped string as list comes as here. And what has happened? A has got combined with E. So you have A and E. The B has got combined with the F. The C has got combined with the G. And the D has got combined with the F. So the successive items of the two iterables have got together and they have created something, and that something has been cast to a list. Let me just let us see what is the type of ZSTR. Let us see this. Let us print. Let's run this again. So this is very interesting result. Let me just show it to you. I have done is, sorry, I'm so sorry. I have not done type. Let me. Yeah, let's see. So this line of code has printed this. ZSTR is of a class of zip. So it's a different class. And if you want to convert it into a list, here you are casting it. So then it becomes this. This is not clear, but let me just do this. Yeah. So now it is clear. Let me just show this. So here, this type ZSTR is class zip. And when you cast it into a list, then it gives you a list. This is a list because you have an outer two brackets. Right. I hope that is clear. Let me just take a test of you guys. Suppose I write here print ZSTR 1. What would it print? Would somebody like to answer?
So it would print B and F.
Excellent. It will print. Let's run it. So, it's throwing an error. Print ZSTR. No. Yeah. That is because I have to write list. Because again, it's a, what I did was, I was trying to use it. It has not been, now it will work fine. Print is not zip object is not subscriptable. Okay. So let me do it differently. Let me write. You see this. Let me write X equal to list print X1. Let's see this. Out of range. Okay. Just 1 second. So it's a list, right? That's not a problem. Then print x, let us do print x0. List index out of range. Okay, maybe there's a problem. Let's not. I don't want to waste the time over here. Let me just remove these 3 lines. Let me come back, but I will solve this problem for you guys. So let us understand the code first. So let us see the. Okay, now let us see the. Let us run it again. Now let us see it again. So here in the first call, this was the first call, and this is the second call, right? And this is the third call. There are 3 calls. In the second call, I've done something different. What I've done, I've taken 3 lists, 3 iterables. I've taken a list, I've taken a second list, I've taken a third list. The difference, this list has got how many? 6 items. This list has got how many? 3 items. And this list has got how many? 2 items. So the way this function works is that it will take only as many items as the smallest iterable. The smallest iterable in terms of the number of items is your list number 3, which has got only 2 items. Therefore, it will print only 1A and 2B bat. So it is you as a programmer or as a script writer, you have to be careful. If you use unequal iterables in a program, in a zip function, then the zip function, without telling you, it will simply truncate the bigger list and print only as many as a smaller thing, right? This is the third one, is that range function. We have not done the range function, so I'll skip this. But I hope this is clear, right? In fact, you can even zip a string with a list. Let me just show you. Suppose you have my variable. I like to use the word my in front of the variable name because that tells me that this variable name is not the one which is belonging to any library, because no library will have a variable name starting with my. But you can do whatever you want. Zip. Let us write A, B, C, D. 1, 2, 3, 4, 5. So it should basically print list my var. I think this should work fine. Let's see. Yeah. So let us just see this code. I've done 2 things differently. First, I've taken the first iterable is a string. The second iterable is a list. And the first one has got 4 items. The second one has got 5 items. So the output will have only 1, 2, 3, and 4 items only. So I hope that clarifies the zip function, right? So we can move ahead. I think we can move ahead. Okay. Okay. Now there's another part of the problem. Just let me just show you this. Using zip to unzip. This is very funny. This is not a very good way of writing programs, but that's the way Python is designed. You can use the zip for unzip. They could have used a different function called unzip, but they use the word zip. So zipping to unzip, the function's name is zip, but what it does is unzip. So if you provide an unzipped list within as a parameter to the function zip, then it will unzip it. And suppose this zipping is of 2 iterables, then it will generate 2 different iterables, X and Y. So I think this will be, the difference is that when you're using zip with simply the the list of iterables, it will zip. But when you're using zip and you put an asterisk and you put the zipped list here, then it will unzip. That is why you have to have at least, because the zipping must be at least, it should have at least two different lists have been zipped. That is why you have to put X and Y over here. The first iterable of that thing will go into X, the second will go into Y. If the zip list consists of three lists have been zipped together, then it will have to be X, Y, and Z. This will become clear with an example. So let us do it. Let us do this. So let me just explain this code to you guys. Okay, so I have taken two lists. The first list is called caps. It contains 4 items A, B, C, D. The second list is called smalls. It contains again 4 items, small A, B, C, D. So in the first, I'm doing the zipping. So I'm zipping the caps with the small, right? And then I'm casting the zip result into a list. And then I'm printing the zip list. So I'm getting from this line, I will get this code. So that is good. A, B, B, C, C, and D, D. So I've got 4 items. That means 4 tuples inside a list. So this list has 4 items. Now check that we have a zipped list of 2 lists. So we have done it. Unzip the zipped list. So now what I'm doing, I'm using the zip function again, and I'm using this zip list over here, but I'm putting an asterisk before it. So now the zip function understands that मेरे को zip नहीं करना है, unzip करना है, और unzip करके जो capital है उनको इसमें डाल देना है, और जो small है उसको इसमें डाल देना है. I have to put the capital. So print cap list, I get back ABCD from this line, and print small list, I get this over here. So this is how zip works as unzip. I hope this is clear to all of you. I think we can move ahead. Okay. Then there's a thing called lambda function. Lambda is called an anonymous function. These are actually not very important from your point of view, but to make the course complete, let me just do it. So that is a function without a name. If you remember, that is normal function. You have to use def, then some function names. Let's call it func name. Then arguments, then colon, then this. So this is the function name in a normal function. But in a lambda, you don't need any function name. You simply use the keyword lambda and the arguments and the expression. So the term is lambda arguments expression. I'll give you an example. Suppose you have to write. Now here in this code, I've written 2 types of functions. This is a normal function, and this is a lambda function. Just let's go over it. In the normal function, I've given the name of the function as square number. Inside the function, I'm returning the square of the number. In the lambda function, the format is lambda x colon x to the power 2. So the moment the Python interpreter sees lambda x, this lambda is the keyword, this x is the variable, followed by a colon, then by x to the power 2. So it will calculate this and put it in the whatever is on the left hand side of the equal to sign, get square. So you can just see this also. Let me just run this program. So let me just show you. Here, I am, see this again and again, I repeat, this is the function definition. And this is the function call, the first function call. So in this case, this line of statement will be executed first. So it will call this function with the number of 10. and 10 to the power 2 is 100. That return value of this function will be printed. We get 100 over here. No problem. Now the second is the lambda. Here there is no function name lambda x colon x to the power 2. So this gets put into get square, and when we print get square with 20, we get 400. So this is a lambda function. I hope this is clear. If somebody has any question or anything, you can ask me, because maybe I'm moving a bit fast. Okay, map function I will skip. Filter, map, generators, these are a bit complicated. I will, maybe if I get time, we'll cover them later on, right? And this is slightly mathematical exercise I will show you on my book. But my book has got some very interesting problems to solve. If you are interested, you can try them out. I picked them up from so these are some conceptual questions. You can try them out. And this exercise is let me just show this for those who are a bit mathematically inclined. Trapezoidal rule of numerical integration. So this is the equation. And I've given one example in my book where I've solved this I've solved this as this function. This is ln is a natural log. So it is ln 2 minus ln 1 with the limits 1 and 2. So those who have done a little bit of class, higher level mathematics, we would know about trapezoidal rule. But if you don't know also, it doesn't matter, because I have not put these things in the main part of my book. I always put them in the end, so that, and I always put in my book, I have put a section called beyond text in every chapter, or in most chapters, like here it is beyond text. So, these are some concepts which you don't need to really know, but if you are really interested, you can. So every chapter of my book has something called beyond text. The differentiate between iterable and iterator. These kind of concepts are there. You can always go over them if you are interested. Making a generator behave like an iterator, and these are the concepts with linear. This is a very interesting, linear congruential generator. You can look into it, and if somebody wants to understand, then we can. Partial unpacking. This is also very interesting. So what is happening over here? I'm giving a list on the right hand side, and I'm putting 3 variables on the left hand side. What will happen? 1 will go into X, 2 will go into Y, and the 3 and the 4 will go into Z. You can see it. You can try it out. And this is, so partial unpacking also is covered. Then assignments, some things are there, right? Okay. So I think we'll move to the next chapter. We'll move to chapter number 6, flow control. I had asked all of you to, read the HTML. So first thing I want to understand 2 things. First, has everybody who's following this class, I guess we have how many? 30 people approximately, right? 38. So has everybody been able to to install Jupyter notebooks on their computers? Because I hope all of you are following along, because computer science and programming cannot be learned unless you actually run the programs, make mistakes, correct your mistakes, find the bugs. You cannot do it. So number 1, that is. And second one, are you able to access my online HTML, which I discussed yesterday? So if somebody can answer on behalf of all of you, then maybe I can move ahead. So are you able to download the chapters in the HTML format? Would somebody like to answer? Anyone? Anyone?
Yes, sir.
Yes, sir.
So you have been able to download Anaconda Jupyter notebooks, and you have been able to also access from my GitHub page. All right. So let's move ahead. So let us go to chapter number 6, flow control. Now, this is a flow control. Like in my book, I always like to start with certain learning objectives. So these are the 8 learning objectives: LO1, LO2, LO3, LO4. LO is for learning objective 5, 6, 7, and 8. The first one is to execute flow control in a program. Then identify and use the various types of conditional statements. What are they? If else, nested if, and while loops. So we will do if else, nested if, and while loops. Explain why too deep nesting may cause problems and how to avoid them. So you should not have too many deep nesting. That means loop within a loop, within a loop, within a loop. That kind of programming is bad programming. And there are ways to avoid it. Using break, continue, and pass. Break, continue, and pass. Decide when to use while loop and for loops. Appreciate the use of range function. We have not covered range function, but I'll try to do it, and its use in looping. Comprehend the significance of infinite loops, because this is a common program. The program got stuck and the interpreter gets lost if you have an infinite loop. Discuss some common errors and listen to avoid them. So these are the 8 learning objectives. Let me repeat. Number 1, flow control in a program. Number 2, the various types of conditional statements. If else, nested if, while loops. Explain why too deep nesting is not a good idea. Using of break, continue, and pass. Decide when to use while loops and when to use for loops. Appreciate the range function, use of range function, infinite loops, and errors. So these are the 8 learning objectives. Let us start quickly. Let us move one by one. So first is if, else. Let me just show you how this thing works, right? Yeah. This is how it works. So this is the beginning, and this is the rest of the script, or this is the place where the the program enters the if, else, if, elif, elif. Let me just write it again, please. So the 3 terms, if, elif, else. Let us see. So if the condition if is true, then it will go here. It will enter the if block. So if the if is true, then the if block will be done. But if it is false, then the elif will be done. If the elif is true, then the elif block will be entered. But if the elif is false, then the else will be done. Let us do this with a proper example, then we can understand. Yeah. So let me just let me just show you the pseudo code. So if, elif, else. Now, I have been repeating this again and again. This condition 1, condition 2, these are 2 statements. These are 2 statements which must generate a Boolean value. That means this whatever is given here, it should either become a true or become a false. Right? So if it is true, then this will be executed. But if this is true, if this is false and this is true, that means if condition 1 is true, false, but condition 2 is true, then this will be executed. But if both 1 and 2, if both are false, then this will be executed, right? Right. So if 1 is true, then block 1 will be executed. If 1 is false but 2 is true, then block 2 will be executed. If both 1 and 2 are false, then block 3 will be executed. All right. So I hope that is clear. And remember, if both are true, that is never tested. If both are true, if condition 1 and condition both are true, that is never tested, because if condition 1 is true, then this is executed and this is never tested. So I hope that is clear. So this makes sense. All right. So let us do this this small script I've written. Let me run this, then I'll explain the code. Enter age. Let me write 13. You are a teenager. Let me just understand. Let us understand this code. So basically, as I mentioned yesterday, input is a way in which, so when this first line of code is run, it stops here and it waits for the user to give an input by printing this line of statement. So enter age was printed, when the box was created, I put the figure of 13. So now what is happening? If your age is greater than 19, so you are a senior. So this is not happening because this is false. If your age is greater to 13, you are a teenager. That means this is happening. And this doesn't happen. And after this whole thing is executed, this is the block. Then the next line exiting is printed. So I hope this is clear. Now let me try with another this thing. Let us try with 3 years. What is happening here? The first condition is false. So this is not executed. The second condition is also false. This is also not executed. And there's no condition here. So then the option is that this thing there, this is executed, and then finally printing is executed. Now remember that there's a Boolean context in front of the if and the elif, but there is no Boolean context in front of the else. Because else means that if both condition 1 and 2 are false, then whatever is left has to be printed over here. So I hope this is clear to you. Right. So we can move ahead. Okay. So there can be an if and else without an elif. So for example, I want to find whether a number is odd or even. The easiest, simplest way of finding a number, whether it is odd or even, is to divide by 2 and see the remainder. That means if you divide a number by 2 and see the remainder, if the remainder is 0, then it's an even number. If the remainder is 1, then it's an odd number. This is for example, suppose you have 15. We divide 15 by 2, then 2 sevens are 14, and you get a remainder of 1. So this is 1. So this is 15 is an odd number. That is the way this simplest algorithm works. So what I've done over here, I've asked give me an integer, and I've converted, again, see note, I've casted it into a integer. Because as I told you that the input is always a string in Python 3.0 onwards. And then okay, let me just show this again. Now this function, mynum %2 will give the remainder. If the remainder is 0, now see, this is not equal, this is double equal. So double equal means that it is comparing the two numbers it is comparing the left-hand side and the right-hand side, and it is generating a bool out of this. So if they are equal, it will generate a true. If they are not equal, they'll generate a false. So if this my number divided by 2 and the remainder is 0, then this will be true. If the remainder is a 1, then it will be false. So I've done this thing and over here. So basically, let me just run the script here. Let me give a odd integer, 71. 71 is odd. Now you might notice that this is the if-else block. So if this was true, then if the number was an even number, then this would be printed, and the code will jump to here. And if the number was odd, then this will be ignored. This will be printed, also the code will jump over here. So this is the statement which will always be executed, irrespective of whether the if block is executed or the else block is executed. So this is a basic, a simple case of if and with the else, right? So let us go to the next one, which is, yeah. Omitting the else clause, that is using an if without an else. So this you can understand like this. Suppose suppose there's a student and there's a teacher. And the teacher says, did you have a bath in the morning or did you do your homework? The boy said, yes. Okay, enter the class. And suppose the boy says, yes. Suppose he says, yes, enter. Suppose the boy says, no. Then the teacher says, okay, you first do your homework, and then enter the class. So this is where how if without an else is used. If the boy has done the homework, then good, enter. If the boy has not done homework, then do something else. Or vice versa. If the boy has done well, do an extra hour of study. So like this. So let me just show this to you. Give that. Let me just first. Let me just show you the script. So what is happening here? It's that variable is number. I'm asking you to give the temperature of the room, and I'm converting the T into a float because the temperature could be 25.3 or something. If temperature is greater than 25, switch on the AC. If not, then print done. And then otherwise, don't switch it on and print done. So let me just show. If I print 24, let me first print 26. So when I enter 26, then this line of code is executed. Switch on the AC. But now let me put say 24. Let me run it again. 24, and then see. You can see that this loop, this if block is never entered, and straight away done is coming. So this was the statement which is coming from here. This 24 I had given to the program, and this part is not executed and done is executed. This is how if without an else works. Let me stop for a second over here and let me just take, because this is a problem with an online class. That we don't really know whether people are following you or not. So let me just stop for a second, and somebody should quickly tell me whether people are able to understand, follow. Okay, I'm getting I'm not very in the, so people are writing yes. Okay, so I guess let's move ahead. Now let's talk about nested if else nested. Let me show this program. Basically, here I'm asking the user to give an age, enter age, and I'm putting it into my age variable. Then I'm checking it. If you are above 18, you can vote. So if this person is above 18 years old, he can vote. Else. But if he's not above 18, if he's equal to 18 or above 18, he can vote. But this part of the block will only be executed if he is below 18. Right. If my age is greater than or equal to 13, then you write, you are a teenager. Else. That means when I come here, that means I am neither above 18, equal to above 18, nor I am above equal to or greater than 13. That means I must be 12 or less than 12. Then I write, if my age is greater than or equal to 10, then you are in middle school. Else. If I come here, it means that I'm neither greater than 18, nor greater or equal to 18, nor greater or equal to 13, nor greater or equal to 10. Here I write if my age is greater than 6, you are in primary school. And if I come here, you are too small to learn Python. I just gave so basically, if you look at this in a graphical format, and in the book I've shown it. Yeah, this I wanted to show. This was the previous one, that if true statements, false rest of the script. So this was that if without an else, if without an else. So this is how it works. Coming back to the other this thing now, nested this thing. Yeah, let us see this. So I've just graphically drawn enter age. So age comes here, age comes here. If you are greater than equal to, it should have been equal to 18, you can vote. So exiting. So you go and go straight to the rest of the slip of the script. Then if you're greater equal to 13 but less than 18, then this is true. You get out of the script. If you're greater equal to 10, then you get out over here. If you're greater than 6, then you come out like this. But if nothing works, then you come out like this. So this is how, so these are all nested if else statements, right? These are all nested. Then I've given one more example. Let me just show this to you also. Okay. So let me just explain the script. So basically, I'm comparing two numbers, number 1 and number 2. So basically, I'm checking whether the two numbers are odd or even. So there are 4 possibilities. Number one is odd, and number 2 is also odd. Number 2 is also odd. So this is the first combination. Then second is 1 is odd, other is even. Then this is even, this is odd. Then both are even. So these are the 4 possibilities. The first possibility, both are even. Second possibility, 1 is even, 1 is odd. Third is one, other is, first is odd, second is even, fourth is both are even. So I have written this program. Now let us see this. Let us enter the first number to be 7. And let us enter the second number to be 9. Let us see what happens. As you can see, first number is 7, second number is 7, first number is odd, second number is odd. Let us see how it worked. So if int number 1 is equal to 0, which is not true, then this will not be, this whole thing will be skipped. Because number 1 is odd number, this is not equal. So this else will come here because number 1 is a 7. Had it been a 6, this would have been executed. But since it is a 7, this is executed. First number is odd. So since the remainder is a 1, so we can conclude that the first number is odd. So we get this statement over here. Now I'm testing the second number. Print number 2 divisible by 2 equal to 0. So, but this is also not true. So this will not be executed. And then this will be executed. So out of these, this first, second, third, fourth, and 5 print statements, the print statement here, this one, and the print statement here, these two will be only executed. You can try it out on your own. I think this doesn't require too much of this thing. Yeah, but the important thing is that how to avoid nested if. How to avoid nested if. I'm just showing you. You can use this technique to avoid nested if else programs. Suppose again, the same script, first number, second number, So what I'm doing in this line, I'm testing whether both are even. If number 1 divisible by 2 is 0, that means 1 is even, and number 2 divisible by 2 is equal to 0. So this is generating what? Suppose number 1 is even, this will generate a true. And suppose number 2 is also even, this will also generate a true. So basically the statement becomes true and as you all know from the AND table, true and true will end to a true. So if both are even, then this statement will be printed. Okay, now let me just write it again. But suppose the first number is odd number. That means I've written here, just note, not equal to 0. Number 1 divisible by 2 is not equal to 0. That means number 1 is odd and number 2 is even. So that means this will, the first number is odd and the second is even. This is how it comes. Now the third is number 1 divisible by 2 is equal to 0. That means number 1 is even, but number 2 is not equal to 0. Number 2 is odd. That means first is even, second is odd, and finally both are odd. So this is the way you have avoided by using these ands. I have been able to avoid this use of nested loops in my function, right? As you can see. This is how it works out. You can see it. I think let's come to the while loop. So these are some of the things about a while loop. Let me just highlight it. So I've written 6 things about the while loop. While loop works as follows. First, the Boolean test expression is checked first. If the test expression is false, the while loop is not entered at all and the program moves to the line of code after the while loop. However, if the test expression evaluates to true, then the while loop is entered and one iteration of the entire loop is executed. After execution of one iteration, the expression of the while loop is again tested. If the test expression evaluates to false, then the while loop is not entered again. However, if the while loop then the loop is again executed. Remember, if the while expression never evaluates to false, you will not be able to come out of the while loop. So at some point of time, the while loop must, So basically, if I can write it on a, let me just see. So that means if I write while, then some condition, colon, and the rest of the statements, which I do, and then, so this will be executed and this should change this condition in some way so that it is true, 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 and sometime it becomes false, then this while loop is exited. We'll understand this by a function. I think let's understand this by creating well, let's take an example, right? So let me just let us first show this. Okay, we can use while, let's just yes. Okay, let's understand this script. There are a few interesting things about this script which might help. The first is that I've written print. No, way. Let me start from the beginning. While loop is said to be counter-controlled loop. We'll discuss why it's called like that. X is acting like a counter. So you have to define the counter outside the loop. Because if you define the counter inside the loop, then you're gone. Then every time the loop is entered, the counter will be reset. So the counter has to be defined outside the loop. Then I've given a print statement number \t. This is one string plus square, which is another string. So there are two strings here. One is number \t is the first string, and square is the second string. Now this \t, this backslash is called an escape character, right? So so if you write this in front of the not escape character, special character. So basically, it is this \t is telling the Python interpreter to treat the t not like a t but like a tab. So what it will do, it will print number and it will print a tab, that means 4 white spaces and then square, just to make the script, the output look a bit more pleasant, better. This is what is happening. And while x is less than equal to 10, print string x plus t plus string x square and cast and concatenate. So basically what I'm doing here is that I'm using string x. That means let us start from 1. So in the first, this will be 1. Then there will be a tab between them, which is here. And then 1 square, which is also a 1. So you get a 1 over here and a 1 over here. And the x is incremented by 1. If you don't write this statement, if you don't increment the x, then x will never become greater than 10. That is why you have to change the value of the counter from 1 to 2. So after the first while loop iteration, x becomes 2, and then it tests the condition on top. 2 is less than equal to 10. Again, it enters, and it prints string x. This becomes, so note, I am converting this x into a string. Then I'm adding that string to a tab. And then I'm adding the tab again to a string. You can add a white space to a string. You cannot add a white space to an integer. Now, suppose I don't do this. Let me just suppose I don't cast it into a string. If I was to do like this, it will throw an error. Let me just show you. Let me run it. Error. Just see. What is the error? See, now what it is saying, unsupported operand types plus for int and string. Basically, it is saying that you are trying to add an x, which is a int, to a tab, which is a string, to another. So this will not work over here. So you have to, I hope this is clear. Okay, so I think we can move ahead and basically let us see the script also. So, very interesting. Now, this is this is called a slicing of the string. So here what I'm doing is, I am converting. So this is a while loop. While S1, this is another very, I will just explain this thing to you. Print S1. So print S1, which is here. This string is this. This is the string. And S1 is equal to S1 to, so basically S1 is equal to S1 to some n. Now, basically what I'm doing, I'm saying that now S1 string का item number 2 से लेकर के, see, this is the start, this is the end. So basically it is saying that S1 strings, you take the item at index number 2 to the end. And since lists are mutable, and you put it back into S1. So what will happen? The first 2 ones will get dropped off, and S1 will become this will become 2, 2, 3, 3, but it will not be printed here. It will be printed in the next iteration. So the second iteration will print this 2, 2, 3, 3. The third iteration will print this, and then fourth, and then 5. So there's another interesting thing you might have noticed. Let me just show it again to you. I have written while S1. So this S1, which is a string, it will evaluate to a false when the string is empty. So in every iteration, 2 items are getting knocked off. So at the end, this S1 will become an empty string. So which will become false. So basically, this S1 will be false, and that is how the loop will terminate. Is it clear to everybody? Let me just stop for a second here and let me get some feedback. Any questions?
Sir, are there some examples of continuous looping?
What looping?
Continuous looping, if they are saying if the loop while loop goes on until the expression is continues to be true. Are there some example of this?
You mean to say infinite loop? That means the loop never comes
Infinite
out.
loop. Yes, sir.
It's very
Infinite.
easy. Yeah. You can do it. Let me do it. Let me remove this. Let me comment this out. What will happen now? Can someone tell me? X will always remain 1. This will go. This will create problems for my interpreter. But let's do it. What happened?
So you have to create the print statement.
Yeah. Okay, I forgot this. You're right. See, it's a this one is infinite loop. This one will keep on printing. This is infinite loop, right? So I'll have to shut down my interpreter. And let just 1 sec. I'll have to stop the kernel. Okay. So let me just remove this and again run it. So now I'm good. Is that clear to everybody? Right? So what I did earlier was I commented this statement out. That means I am not incrementing the x. That means the x is always 1. So this while loop will always be true and we are not able to exit. It creates an infinite loop and the interpreter gets stuck. That is why I had to stop the kernel. I did a restart from here, and that's how I was able to run again. Is that clear to everybody? Shall we move ahead? Right? Anyone? Any questions? Okay, let's move ahead. Break, continue, and pass. You can read these things on your own. I want to cover the more important things while with else. You can, I think these things you can do on your own. Do you want me to go over these things or you can do on your own? So anybody would like to answer for the class?
Sir, if you can just explain it from the scratch. मतलब ऊपर से बता दीजिए एक बार.
Okay, बता देते हैं. तो जैसे okay, now I'll give an example. All right. I got lost in my listening. While with else you can study. And
Continuous and past statements.
yeah. I was here. I forgot. Yeah. Where was I? Break, continue, and past statements. Yeah. Okay. Let me open my book. So I'll read it out from the beginning. Yeah. Break statements are used inside loops or nested loops. So if you're using inside a loop, which is not nested, then the break statement will make you exit the loop. But if suppose you are in a nested loop, that means you are in a loop which has an inner loop, and you put the break statement in the inner loop, then it will come out of the inner loop to the outer loop. In case the break statement is in a loop which is not nested, then the break statement terminates and the loop containing the break terminates this loop. So the control of the program will pass back to the statement immediately after the body of the loop containing the break statement. However, if the break statement is used in nested loops, then the inner loop containing the break statement will terminate. Further, the control program will flow back from the inner loop to the outer loop. Right? This is very simple, very easy. The following points regarding continue are noteworthy. Continue is very useful when you don't want to terminate a loop but only want to skip the rest of the code in a loop. So with conjuncted loop, it does not terminate, only the remaining statements are skipped. The past statement does nothing at all, it's simply a placeholder. So read it on your own. I think this much study you should do, because I should not do too much of spoon feeding also, because I feel that, um, so examples are there in my this thing, but this is a example of a break. Let me just show you. So here, what is happening? Break kar raha hai, so you can do on your own. Let me just skip it. Then while with else, you can do these things on your own. Okay. Past statement. Past is basically for writing what is called, placeholders. Suppose I'll give an example. Past, suppose you're writing this code. If x greater than z, then do something. If else, do something else. Suppose you are just writing your code, you can't do like this, because comments are not statements. So this is basically if x greater than equal to 0, else. So that means there is no statement inside the if block. Let me just show this to you. Let me become clear to you once let me just show this to you. Let me just show you. Okay. Let us run this program. Yeah. So what it is showing? Basically, this do something is not a statement. So basically, it is something like this. It is something like this. So Python interpreter is treating it like this. So that is why I think expected and indented block. That is what the interpreter is saying, that after this X, I expect something over here. But if I write a pass over here, 1, 2, 3, 4, pass, I'm good. Now I'm good. Yeah, here also. Yeah. See, now it's working. Let me write here, just to show you that this is X. No. Print. Less than or equal to. Now let us run it. Oh, sorry, this has to be 1, 2, 3, 4. See, did you notice when I did like this, then this print will be executed because there is no indentation. So this print is not part of the else. But if I put 4 white spaces, now let me see. Only since X is 5, only X is greater than 0, so greater than 5. This is executed. So this pass statement, if I don't remove this, if I remove this also, I'm good. So basically, pass statements are useful for writing your functions where you have not yet defined the body of the function. You have simply decided that you need a function or you need a condition, but you have not decided what is inside the condition. I hope it is clear to all of you. So we can move ahead. Infinite loop we have discussed. For loop you can do on your own. And then nested for loops also you can do on your own. Then range function. Let me come for this. There is a function in Python called range. It's a very useful function. Let me just it is range. Let me just show you in my book how it works. Yeah. You see, this is called the function header. This is called the function header. It has got three possible arguments: start, stop, and step. Out of these three arguments, two are enclosed in square brackets, this one and this one, and one is without any bracket, stop. That means this has to be given. Right? So you can do range 5. This means that the stop is 5. If you write range 1, 5, then the Python interpreter will understand that the 1 stands for the start and the 5 stands for the stop. If you write range 1, 5, say 2, then 1 becomes your start, 5 becomes your stop, and 2 becomes your step. This will become clear within. Achha, there's another thing. Let me just show this to you. If you write range 5, then the Python interpreter automatically will give a default value of 0 to start. So it will become technically range 5 and range 0, 5 will give the same output. Right? And the step will be presumed to be 1. Therefore, range 0, 5, 1. So this, and this, all three of them will give the same output. We'll just work it out, right? We'll just do it. So yeah, I've shown it here also. That range 10 is the same as range 0, 10. I've shown it here in my book, and the same as range 10, 0, 1, right? That means if one parameter only is given, it will be presumed to be stop. If two parameters are given, they will be presumed to be start and stop. And if three parameters are given, they will be presumed to be start, stop, and step. Now let us see this. So range n will create a sequence from 0 to n minus 1. Note, it is not n, it is 0 to n minus 1. The number of items is n. The number of items is n because the index of the first item is 0, because the first item will be created will be 0 and the last item created will be n minus 1. As you know that if you have to count from 0 to 5, then you have 6 items: 0, 1, 2, 3, 4, 5, 6. So here if you're doing 0 to, if you're doing range 5, this will give you an iterable or a sequence which has 0, 1, 2, 3, and 4 only, not 5. Similarly, if you start range m, n, it will create a sequence from m to n minus 1 with a step of 1. And if you use m and k, it will create from m to n minus 1 with a step of k. It will become clear. Let us see, the full form returns a list in the following format: start plus step. If the step is excluded, it will be 1. Start plus 2 into step, up to, but not including stop. Now there can be many variations. Suppose the start is bigger than the step, there's a problem. And suppose this the start is bigger than the stop. If the start is bigger than the stop, suppose I write range, some rascal writes range 10, 5. Right? So this will give you an empty list. But suppose I write range 10, 5, minus 1, then I'm good. Then we'll take out from 10 to 5, but not including 5. So this will become clear. Let us do this a little bit of this thing. So these are very useful. This example is there. Suppose I want to print the multiples of 3. Right? Let me just show this how it works. So what I've done, let me just show this. For counter in the range 3 to 20 with a step of 3. That means the first number will be 3. Then the next number will be 3 plus 3, which is a 6. Then a 9, then a 12, then a 15, and then an 18. But it cannot be 21, because in any case, now let me just change this. Let me make it 21. Now this, let me run this again. It is just I want to show you. So it is start to stop, but not including stop. So ideally 21 is generated, but 21 is not printed because 21 cannot be included in the range function. So I hope this is clear, and I think we can move ahead. So these are some more nuances using in and for and iterables and quite a lot of. I think we have covered chapter 6. So would anybody like to put any question, any doubt, any comment, any statement, any observation, anything? Otherwise, then we will move to the next chapter, which is classes. Anyone? Quickly. Are we good?
Yes.
Yes. Okay. So let us move to the next chapter, which is classes. If you remember, I think it was chapter 13, right? If I remember correct. So this thing is quite irritating. It's always coming in the. Okay. So let me see page 316 of my book. No, this is chapter 14. Okay, let me just digress a bit, right? Because this is one of the most important concepts in any programming language. You are doing, whether you are learning Java or C++, you need to understand. Let us first look at the learning objectives. Understanding the basic concepts of object-oriented programming. Realize that Python does not have function overload like C and Java, but it has through arg and coarg. I'll talk about this. Using the double underscore init method equivalent to constructor in C++ and Java. We'll talk about what are constructors in Python. Understanding the concept of instance method, class methods, static methods, and decorators. So this is a bit decorators is slightly advanced concept. So most beginners they should not be learning decorators initially. What ideally would be I tell you all the other things, but leave out decorators, and then once you have become familiar, once you have started writing your own scripts, then maybe come back. Then what about data hiding, data mangling, and dynamic data binding, and the built-in various class attributes? So this is going to be quite heavy. So on purpose, I'm taking up this chapter because we cannot cover classes in one session. So what I will do is, right now we are at around 8:30. So what we will do is we will cover part of this, and then we will try to finish this concepts in the next class, right? So let us go over it. There are two major programming paradigms. Paradigm, you can think of a system of knowledge. One is a procedural oriented programming, and other is object oriented programming. So procedural oriented programming and object oriented programming. Let me just come to something basic, but let's talk about something else. Let's talk about what is called data structures. I'm not very, I am data structures. So I will not go into the technical definition of data structures, but your lists, tuples, sets, dictionaries. What are these? These are basically all data structures, right? So in any programming, in any program which you write, you are basically going to be doing two things. So any program, you are going to be doing two things. What are they? You'll be using data, or you'll be having data. And you will be maybe manipulating the data or doing something with the data. Manipulating or doing something with the data. So this, what does it mean? You have data and you manipulate the data. So to have data, you will need data structures. And to manipulate the data, you will need functions. Let me repeat, to have the data, you may need some, unless you're dealing with very primitive type of, like integers and all are not data structures. You know, bools, integers, and your floats. These are not data structures, but lists, tuples. So these are called inbuilt data structures. Inbuilt data structures. Inbuilt data structure. You see, if you study the evolution of programming languages, one of the first languages which was there was C. And then it became C++. I forget that there was another language which
Pascal.
motivated, not Pascal, I think it was Haskell, I think, not Pascal. Maybe, I'm not so sure, but basically C was a procedural language and C++ is an object-oriented language. This is the only difference. But C is a subset of C++. That means that whatever you can do in C, you can do in C++. But whatever you do in C++, you may not be able to do in C. I'll just show you again. That means if this is what you can do in C, then this is what you can do in C++. That means this part you can do in C++, but not in C. But whatever you do in C, you can do in C++. Now, there was a very, now let me just, maybe I've not introduced the topic properly. Let me just introduce it like this. Suppose I wanted to create a data structure. I want to create a data structure which simulates a human being. So the first thing I will do is what I like to call as data abstraction. Just listen to these words carefully, data abstraction. Basically, a human being is consisting of hundreds of things: height, weight, sex, age, color, nationality, so many things. So, but I say that in my program, the human being will consist of maybe only three things: sex, age, and say height. Right?
Sir, we can also say attributes.
Yeah, attributes. Yeah. So what I've done, out of the hundreds of possible attributes which a human being might have, I have abstracted 3 or 4 of them. It doesn't represent the person per se as such, because it doesn't, but I will say that my human being is consisting of only 3 items: sex, age, and weight. In my book, I've given an example. I'll just show you. Let me just let's stop. In computer science, one tries to model the real world. The real world consists of objects or entities which have characteristics and do some action or behavior. So, dunya mein, if you think about objects in the world, then they have 2 things. They have entities and they have got some action or behavior. So in effect, one is trying to model or represent objects in the real world through two things: characteristics, which you call as attributes, action and behavior, which you call as function. A Python object is therefore an abstraction of for data. In Python, of every no, this is not this thing. Every object has an identity, a type, and a value. This forget about this concept of. Let's talk about data abstraction. Let's talk about this concept. When you want to model a real world object, you only take its essential or unique characteristics or those characteristics which matter. For example, consider a person who has applied for a driving license. The person may have, I've listed out 9 characteristics: name, age, sex, height, weight, income, address, nationality. But when an issuing authority issues him the driving license, it may be interested only in some of these characteristics. In your driving license, normally the income will not be given because it is not of any concern generally to the issuing authority whether you are earning large, whether you are a rich man or a poor man. Similarly, generally, if the driving license is only being issued to Indians and not to foreigners, then nationality also doesn't matter because it will not be issued to the foreigner. Similarly, weight, generally, unless you are somebody abnormally heavy or abnormally light, weight also doesn't matter because weight is not a factor. So I say that I write name, age, address, and whether he knows how to drive or not. So these are the 4 things which I will write on the drive. Obviously, if it could be that he knows how to drive a car but not a scooter, or a scooter but not a car, or a truck but not a trailer, whatever, right? So as far as driving license data is concerned, a person can be represented by his name, age, address, and driving ability. The first 3 of these, name, age, and address, are characteristics or properties of this person. And the last one, that is driving ability, is the ability or capability to perform an action. So therefore, I'm trying to convert the person into 4 things, 3 of them which are attributes and 1 of them is an action. This is data abstraction. And now this is the understanding. Let me just give the definition for completeness. Abstraction is the process of keeping only the most essential characteristics by removing or hiding the non-essential ones. Through abstraction, one can decrease complexity, making it possible to create a model of the object. So what is a driving license? It's basically a model of the human being. And that model contains only 4 things. In my example, name, age, address, and a ability, which is the driving ability. Are we clear so far? Let me just, if anybody has a doubt, because these concepts can become a bit hairy, it can it can confuse a person who is listening to these things for the first time. Okay, from computer science, where you are going into human beings and driving and all that. But basically, I'm trying to give you an example of how the class concept works, right? Right. So let us come to the class. What is the concept of data encapsulation through class and object? What is the class? In programming, one tries to model the real world. The first step in this process is the data abstraction. So whenever you want to create a class, the first thing you want to do is to pick out those characteristics and those activities. Suppose, now I'm giving an example. Suppose you want to model a car. A car may have many characteristics, again, or properties such as color, make, model, year of manufacture, top speed, fuel efficiency, mileage. But we decide to keep only its color, model, and top speed as its essential characteristics and behavior. Further, you may define the car to be a sports model if its top speed is more than 100. More than 100 kilometers. So now you have abstracted 3 characteristics of the car, namely color, model, and top speed. Further, you need one method to find out whether it's a sports model or not, depending upon whether the top speed is more than 100 or not. So the car could be represented by something like this. So there are 3 variables: color, model, top speed, and a method which sees whether it's a sports model or not. Color is a string, model is a string, top speed is an integer, and that means it is not a float, it is whole number 1, 2, 3, 4 like that. It cannot be 10.5. And there's a method which checks whether the car is a sports model or not. So these are the, so I have reduced my car into these 4 things: the color, the model, the top speed, and the ability of, and one function which tells me whether the car is a sports model or not, depending upon whether its top speed is more than 100 or not. So this is the encapsulation of a car. Are we good so far? Anybody? Any questions? Okay, we'll move ahead. Okay. When a programmer writes code for a class using all the OOP concepts given above, then he has created a kind of a factory which can be used to create instances of the car class. If you think of it, there are no cars in the real world, but only instances of the car. It's a very interesting concept. If I ask you, show me a car, you say, I can't show you a car. Say, why? He says, I can show you a Maruti, I can show you a Zen, I can show you a whatever. I can show you a type of a car, but I can't show you a car. But in your mind, in your brain, in your thinking, you have the concept of a car, which is what you have abstracted from all the cars you have seen. The car has to have 4 wheels, it has to have, one driving seat, it has to have this, X, Y, Z, whatever. So that is the same thing with a class. A class is something similar to a car, but a Maruti, which is a type, which is a particular instance of a class, is your object. So if you have a class called car, then this class can create instances of car, and those instances can be given names like Maruti or whatever you want to give. So this class car is like a factory. It can produce a Maruti, it can produce a Zen, it can produce XYZ, whatever, right? Okay. The distinction between a car and an instance of a car is subtle but important, very important. All real world cars are not cars, but instances of cars. As I said, if I ask to show me a human being, you will say there are no human beings. There's only Anurag Gupta or X or Mr. Balaji or whoever the person is. So there is no human being. Human being is a concept which is in your mind. So in programming, human being is a factory which produces instances of human beings. Similarly, car is a factory which produces instances of car. So if you have a class called car, it can produce cars, but it is not. It can produce instances of car, but it is itself not an instance of car. It's a factory of cars. I hope this concept is clear. This is a bit confusing. Then inheritance, we'll not talk about inheritance right now. We'll come to it later on. Polymorphism. But to understand polymorphism, you need to understand inheritance. Okay, let's do inheritance a little bit. Why this is important? Because inheritance and polymorphism is what makes modern programming languages so powerful, and what makes object-oriented programming so powerful, right? So I'll give an example. I have a class called car parent, which has 3 instances: color, model, and top speed, and a method, this thing. Now I want to create another class of cars which consists only of, say, diesel cars or petrol cars. So everything else in my new class of cars, no, remember, the new class is not an instance, it's another class. So what I will do is I will take these 3 variables from the original car class, and I will add one more variable to it called fuel type, which is also a string, new property, and my new class becomes a child class or inherited class. So this is the beauty of programming, of object-oriented programming. Most people, what they will do, they will take a class. They don't need to know everything which is inside the class, but they just want to add certain characteristics to it, and they are able to write their own scripts and programs. That means the program becomes highly reusable. That means the program is highly reusable. The classes are highly reusable. The libraries become highly reusable. People can modify, people can change, people can add, people can remove things, and that is how this whole thing works. So this is the concept of inheritance. This will whatever I am telling you, I'll prove it, show it with examples. I will not tell you anything which I for which I cannot give an example. So I will tell you these things, and I will give you specific examples to prove that whatever I'm saying is correct, right? Then comes the concept of polymorphism. This is a very okay. Let me just try and explain. Maybe you may not understand in the first go. Don't get worried. These are concepts which are a bit complicated, but with little bit of effort you'll understand. So suppose I have a car class, and let's call it car parent. This is a class which produces cars, like in the previous year. And from this class, I create another class, let's call it car child. Whatever. Now let us create an object of the class parent. Let's call it C1 or CP. This is object of the type class. How we'll do it, I'll talk later. And let's talk about let's create a car of the child CC, which is a child class. Now there are two classes and two objects. Now, depending upon, there might be some methods in car child which override the methods of the car parent. But that means that, like you remember, like we had this thing of a global variable and a local variable. Within the function definition, the local variable was dominating over the global variable. Similarly, I might be able to write the same method in the car child. Suppose I write the same method in the car, that method with the same name in the car parent and the car child. And I create two objects of the child of the class parent and the class child, two objects. And I call that method. And I call that method which is existing both in the parent class as well as in the child class. Now, the Python interpreter will see the object, CP. Oh, this is an object of the type car parent. So I will execute the method of the parent class. But suppose I give to the interpreter a method object of the type child, and that same method exists in the child class also. Oh, this guy is a child class, so I must not execute the method of the parent. Rather, I should execute the method of the child. So that means that dynamically, that means on the fly, that means without knowing from before, when I give an object to the Python interpreter and with a method, and I ask it to do a method, the interpreter is smart enough to first check whether that method belongs to the parent class or the child class. If the method belongs to the parent class, it will execute the method of the parent class, depending upon the object. And if the method is of the child class and the object is also child class, it will run the method of the child class. So I think let me just stop here for a second because these concepts are a bit. Let me take some feedback from the class. Are you guys able to follow so far? It's all theoretical. Anyone?
Sir,
Yeah.
sir, what is the difference between the instances and child class?
Instances and child class. See, when you have a class, if you create an object of that class, it's an instance of the class. So instance of a class is nothing but an object of that class type. And child class is another class which you have created from this parent class. So you have created one class parent, you may create another class child, and you may create an instance of the child class also. So there are four things: parent class, child class, instance of parent class, instance of child class. Does it answer your question?
Yes, sir. Understood it, sir.
Yeah. Okay.
Yes, sir.
So we can move ahead. Operator overloading we have covered. Function overloading, it's not possible. You see, in certain languages, you can write the same function name, for example, ffunc fx with two variables, 1 and 2, an fx with 3 variables, 1, 2, and 3, or fx with different types, there's the 2 integers or 2 strings. But in Python, you cannot do this. If you define the function twice, then I've given an example. Then the second implementation, and then the first implementation, which one? The second definition will prevail over the will prevail. So if you this is called function overloading. का मतलब क्या हुआ? Function overloading means that depending upon the number of parameters or the type of the parameters, the function should act differently. This is possible in certain programming languages. You can write a function with 2 parameters, it will behave differently. You can define a function with 3 parameters, it will behave differently. But in Python, if you do it, the first instance will be ignored and the second will be executed. This is a very small point, not very important really. Let's go further. Okay. Okay, this is another thing very important. As per Python style guide, class name should always begin with a capital letter. Let me talk a little bit about naming conventions in Python. I think that's, let me just search for this thing. Just one sec. No, I'm okay. I'll have to locate, but I'll not go because we are getting confused. We are not getting confused, but we'll miss out on the important things. So let me not go over that. I'll just tell you some important naming conventions. And first is that class name should always start with a capital letter. So if you are writing a class, you should always use a capital letter. Like for example, here. Right. Okay. Let us talk about this. So okay. So a typical format for writing a class in Python is the keyword class. Class is a keyword. That means it is something which is contained in Python. Then class name, whatever name you want to give, followed by a colon, and then 4 white spaces and the statements 1, 2, 3, 4, whatever, and this will become a class. Let me just show this to you guys. Let us write a simple class. Let us write a simple class. Yeah. Yeah. Because classes is a very important concept. If you don't understand anybody, please ask me to stop, and there's no point in running over things till you understand. So let me just run this program. Okay, let me just run it and then I will explain it to you guys. Okay. So this is a class definition. I've created a class called person. I've used the keyword class. I've given the name of the class to be person. I followed it by a colon. Then within the class, I've given 3 name variables: name, age, and sex. So these are the 3 variables: name, age, and sex, right? And I have given them a default value because in Python, I cannot write name without a value, age without a value, sex without a value. I've given name equal to XXX, age, which is a string. Obviously, name will be this will be a string. Then age will be an int. and sex will also be a string. Right? Now, what is happening? So, now let me again tell you, this class is a local scope. Class is a, let me just wipe it out and rewrite it. This class is a local scope, and this class is not a runnable code. That means until you call this class, until you create objects of this type, this code will not be run. That means the interpreter with this will be the first line of code which will be executed. P1 is equal to person within bracket. This is how you create an object. You have to use these brackets always.
Just like a function.
Just like a function, yes. And that is why this the conventions are so important. When if you are importing something or using a library, and you're writing, if it could be P1 is equal to person, this thing, and P2 it could be equal to capital P person. So by person, so by looking at this code, you'll know that this is a function and this is a class. So P2 is an object, whereas P1 is a return value of a function. Is that clear? So this naming convention is very, very important. In fact, many, a lot of these teachers in schools, they teach kids Python, but they don't teach these basic things like naming conventions, which is so important, because you cannot read good code, you cannot write good code. A couple of years back, I happened to see the CBSE 11th book for Python, I think written by CBSE and CRT. I was so disappointed. They were not following any of the naming conventions, and you cannot be a meaningful programmer or a code writer if you don't follow these. Let's come back, right? So what I've done here, I've created two objects, P1 and P2. Okay, now these three attributes, these are attributes of the objects, can be accessed by so-called the dot operator. Dot operator. So when I write print P1 name, P1 dot name, this variable will be accessed. When I write P2 dot age, then this will be accessed. So P1 name is triple X, P2 age is 0. So this is what is now what I'm doing. Now I'm let me just clear this out and write it again. Now what I'm doing, I am reassigning the name to Anil. P1 dot name is equal to Anil, right? So, and P2 age is equal to 20. So now when I print P1 name, P1 dot name, I will get Anil. And when I print P2 dot age, I will get 20. Is it clear? Anybody, any questions so far? And you see, these objects can also be put in lists. I could write this good, no problem. Let me see if I print. So this is giving the object, person object in the memory. First, this is the first item, and this is the second. Of course, this is not relevant, so we don't have to go for this. I was just trying to tell you that the power of the programming language and the power of things like data structures like lists, they can contain integers, they can contain floats, they can contain bool, they can even contain objects. So am I clear so far? Any questions so far? Any questions?
No, sir.
Okay, let's move ahead, right? Where is that thing gone? Yeah, here it is. Okay. Now there is a problem with this. There's a problem with this class person. What is the problem? Suppose I wanted to create a person with the name something, age something else, and sex something else. The one way could be that I create a person like I did P1, and then I alter it by using these kind of statements. This is the one way of doing it, but this is a very complicated way. There is a simpler way. There's a simpler way that I can pass the variables to the class, and when I pass the variables to the class, the variables will go to a method inside the class called the init method. Let us just see a piece of code, and then maybe you can understand. So now see this code. Here I have written the same person, but I have defined a method inside the class called init underscore init underscore, and I've given it self, name, sex, and age. And then I have given the name to the my name, the sex to the my sex, and the age to the my age. So this person class, if you create an object of this class, it will have 3 attributes. Those attributes will be my name, my sex, and my age. But when you are creating the object, you have to pass it 3 variables like this. So let us just see this. So I'm creating P1 person. Now notice that when I'm creating this person by using the class name person, I'm giving it 3, 1, 2, and 3. Right? So this Sunil Kumar, which comes here, will go into my name. This sex, which is here, will go into my sex, and the age will go into my age. That is why when I print P1 dot my name, I will get a Sunil Kumar. When I print P1 dot my sex, I will get male. And when I print P1 dot my age, I will get 19. Is this clear? I will just run this code also so that it becomes clear to all of you guys. So let us run it. Okay, so let us run this. Right. So you can see that when I'm defining the person, I am not having any brackets. But when I'm calling the function, or rather when I'm creating the object of the, when I'm writing the class, I'm not giving any brackets. But when I'm making object of that class, I'm giving it this thing with as many variables as are required in the init method. Now, one more thing you will notice. Init method takes 4 variables: self, name, sex, and age. Now, the self is a very important concept. Basically, it says that the object which it is creating, that means itself, its name will be my name, its sex will be my sex, its age will be my age. Why the self is there, I will explain later on, but you just understand this basic concept. So this much I hope is clear. So we are at 9 o'clock. Should we stop here? Would you like to continue? Would somebody like to ask some questions? Because okay, let's finish this part, right? So I have explained the concept of right. Let's just go back to the book. Yeah, a class which has an init method. So let me just show you what I've written here. There's a serious problem with the person class created. All the objects of the type person have the same name, zeros, the xxx, this I've already. Suppose you wanted to be able to create object type person with name, age, and sex as per your own choice, and how do you do this? The answer is to use this is, see, if you are coming from a programming background, the same thing can be done in C++ and Java by using what's called a constructor. All modern object like C, I have constructors to initialize the instances of a object as per the parameters supplied by the creator of the object. What is a constructor to a class? When you create an object of a class, you may at times want to initialize with certain values. For example, you may want to create an object, say P1 of class type person with name, age, and sex supplied by the creator of the object. To do this, you must define a constructor in the class. In Python, this is done by the init method. This method has a double underscore on both sides. So double under is equal to dunder, which I had explained, I think, in one previous class also. So init method is basically dunder method of Python. There are many such methods of this thing. The other important concept is concept of self. Concept of self. Concept of self. When you create an object by using as shown above, then you access the properties of the object using the dot notation, p1.name. However, inside the class, you have to use the variable. This is done by using the keyword self. See, when you are outside the class, if you remember, we created an object p1, which was person. So when I want to access the properties or the attributes of p1, I will write p1 dot something, whatever attribute. So I am doing this outside this class definition. But inside the class definition, if I'm accessing on any of the attributes, then I have to do self dot that attribute. Whatever that attribute. I think it's clear. If it's not, maybe it will become clearer as you do these things, right? So let's do this. Is it the same? Yeah, we've done it. This we have done. Okay. Let's do another example. Okay. A class which okay. So now I'm making things a bit more complicated. A class which has attribute init and also has default values for init. So basically, I'm again creating the same class person, and I'm giving it 4 variables: self, name, sex, and age. So typically, whenever you create a class person, you have to give it 3 variables at least: name, age, and sex. But what I've done, in addition, I've also given the default value of age equal to 20. So I can manage with 2 variables also. If I give only the name and the sex, the age will automatically be taken as 20. This is the same concept as is used in functions. So default values. So I have given a default value of 20 for the age, and name sex self dot name is equal. See, now this is very interesting. Self dot name equal to name. Now this name and this name are 2 different names. This name is what was passed to the class definition, and this name is the variable of that particular object or the particular class. So this is the convention. We generally use the same name for same this thing for both name here also. But remember that this name is what is coming from the class constructor call when you are creating an object, and this name is the variable of that particular object, right? So let us run this this thing. Did we do it? Let us run it, then I'll explain it one by one. Okay. So again, same class definition, same init method with the default value of 20. And I'm creating 2 objects. The first object's name is Anju. The second object's name is Sunita. Anju is also of the class person. Sunita is also of the class person. To Anju, I have given two attributes, Anju Kumari, which will go into name, and female, which will go into sex. And I have not given any age, therefore the age of Anju Kumari will be the default value of 20. Whereas in the second case, I have given three variables, Sunita Kumari, sex, and age 25. So now when I ask you to print age Sunita.age, it will give you a 20. But when I ask you to print, Sunita.age 25, and when I ask you to print Anju.age, it will give you 20. Let me just clear it out. So this Anju.age will be 20 and this Sunita.age will be 25. This is how it works. So I think we should stop here. It's already 9 o'clock and I do have some other engagements, so I don't think I'll be able to continue. So if anybody wants to ask me any question, any observation, statement, suggestion, whatever, this is the time to do it. And if you want to do something, ask me. Otherwise, one last thing I can do is, there's a very interesting article I had written a couple of years back on duck typing. So I'm putting the link over here, so you guys can. It's on an open source magazine called opensource.com. What happens to the code if we don't use self? It will throw an error. So let's do it. If we don't, so if let me just do it. Because let me just do it. Huh? I don't know. I'll have to check. But a person will not have an that now the error will be here. Let me just do it. Let me write print p1 dot name. Now it should throw an error. Yeah. Person has no attribute name. So name equal to name it has taken. That means this has become this name, which is, so will not work. Yeah. Any other question?
Can we use any other word other than self?
You can, but you shouldn't.
Okay.
You can, but you shouldn't. As I said, this is the standard. If you write anything else, people will not understand your code, because any programmer worth his salt will use only and only self for referring to an object, to the attributes of an object inside the class definition. You should never use. If you want to just try it out, do it. So let us make selfish. So you could do selfish. Yeah. Let's see. It's good. It's running. Fine. Right. Okay. So let us do selfish. Okay. So any other question? Should we stop here? So I think what you guys can do is you can follow the rest of this chapter. It's quite a long chapter on classes. So I'll go one by one. I'll add subtle differences, subtle new things with every class. And that's like I started with the class which had no init. I started with the class from here. I started with the class which had no init, right? Then I added the class with an init. Then I added a class with an init with the default value, right? Then I will add something more, then something more, like that. So I will slowly I will, and then I will add a class which has attributes as well as member functions or class methods. Now this method, these three functions are there: setL, getL. Read it. If you read it, then I've written a function over here, which is outside the init. So this is a class function. I have given an example in my book. Suppose you produce cars, right? So as a car, you are only interested in a car. But suppose you don't care how many objects are being produced by the class, right? So if you are a car buyer, you're only interested in the attributes of that particular car. You don't care how many cars that particular factory is producing. But suppose you're the factory manager, then you might want to know, okay, how many objects have been created. To do that, you can have a attribute called count zero. I'll cover all these things. Then function decorators, we'll talk about decorators. Then data hiding, mangling, pseudo private members. Then built-in one. So these are the things I will cover in my next class, whenever that is. So anything else? Otherwise, I'm stopping over here. All right. Okay.
Yeah, good night, sir.
Okay. Good night to all of you, and just look over all these things, and it should work out. Right.